Now, we don't need to create a new project. Can we just go back to not person tester here. Can we just go to last week, week number 7, lab 2? I think that's what we need. Okay, we already got the point over there. That's what we need. If you click on the point class in week 7, lab 2, that's all we need. So over there, you got the X and Y attributes. So we're going to actually do something to it. Okay, let's create a method that we talk about this morning's lecture. Okay, do that quickly, and I'll show you how we can deal with that. Okay, so now we're going to define an accessor method. From the TA, or is from you guys? Good. Okay. So I just want silence, just easier for me to concentrate. Okay. So now the first one I would like to do is I want to define an accessor method. Oh, let's do mutator here. Mutator method which moves a point up by certain units. So since a mutator method returns void, does not return anything. And then we can say move up by, and then integer I units. It's from you guys or somewhere, right? Or I'm just having illusion. Okay, good. Okay, so now let's have this. We have y is assigned to y plus I. Okay, so how do we do this? So we have move up by. Let's test it right away. Let's go to the point tester here. So now we have 2, 3. How about just test it right away? If I say P1 the move up, let's say by 2 units. Before this, let me print out something for you. You can say system.out.println. Okay, we're going to say this plus P1.x plus, comma, plus P1.y. Okay, plus, like that, before we move up. After we move up, we're going to say another thing over here, like that. So it used to be 2, 3. After we move the point up, it should be 2, 5. Agree? Let's try. Used to be 2, 3. After moving up, we got 2, 5. Okay? Let me just make it a little bit more readable for you on the output. You can say system.out.println. After moving up for 2 units. That's what we have. Okay, now I want to demonstrate to you. Remember in the remember Hongju actually asked me the question in the morning to summarize what I put on the board over here, right? So let me summarize again part of it. Okay? So now moveUpBy is a mutator method, right? If I try the following, if I try to say I want to get whatever value it returns. If I say, for example, double I is assigned to P1.moveUpBy 2. First of all, that wouldn't compile. It's an error. Let's see what the error is. If you move your mouse over, it says that type mismatch cannot convert from void to double. What it means is this. This method here, moveUpBy, returns void, which means nothing. You're trying to store void into double variable. So of course, doesn't make sense. So this is not good. So that's an error. Or on the other hand, if you try to say system.out.println P1.moveUpBy by 2. This would not compile either, right? Because again, you can see that print line over here. If you move your mouse over, it's not a, so now the method print line wants some value, but somehow you're just getting a method which returns void, right? So that's not good. So these two lines are what I said in the morning why they are not good. Okay, any question about this? Okay. Let's go back to point. Now I want to define an accessor method. Accessor method which returns a point objects. How do we do that? First of all, the return type is going to be a point. Whenever you refer to the class name in Java, as we said in the morning, it refers to a type, reference type. So point, just type it carefully, moved up by, like that, integer I. I'll show you how to run a debugger in just a moment. It's actually quite important. You know how to use debugger. Okay. So move up by. So now, let's see what happens. You can see there's an error already. It tells you that this method must return a result of type points, but I'm not returning anything. For your assignments, if you want to get something to compile just quickly, for this one you can say return null. The Eclipse will just shut up for now. But that's okay. You can fix it later. Okay. Now, for this one here, how do we return something that's more meaningful, right? That's something we had to worry about now. We had to create a new point objects, right? So we're going to say this, point, new point. I'm going to just use the name, the same name as your slides. New points, new point over here. It's going to be the same as the current attributes, x and y. And then we're going to say mp dot move up by I, like this. And then return mp. Okay, that's what we do. Okay, any question about this? So I kind of explained this in detail in the morning, so hopefully that's clear. Okay, but I'll show you how to use the debugger to check it in just a moment. Okay, let's go back to tester. I want to show you the debugger first of all for moveUpBy. Can we put a breakpoint over here right before we try to do p1.moveUpBy? Let's see what's going to happen over here. Okay, now let's launch the debugger here. You can see we're now in this line here, right? We're now in this line here, right before we try to execute p1.moveUpBy. But let's try to see what Eclipse can offer us. If you move your mouse over p1, it tells you that p1 is an object of type point. And then it has x 2.0, it has y 3.0. Okay, that's something very useful. And then now we want to see exactly what moveUpBy would do for us. So now we can say something you have done before. You can step into. So far you only do step over. Step into means now I'm trying to make a method call, but I want to see exactly what that method does to the attributes. So that's why I can say step into. Before we didn't really have this kind of method call, that's why I didn't show you, but now we do. So now just remember that we got P1 here, which has got 2.0 and 3.0. And remember again, P1 is so-called the context objects. So when I step into the method, the x and y value are going to correspond to the x and y of the context objects, which is 2 and 3. Okay? And also the argument value here, which is I, is 2, right? So now let's step into. This is what we usually do, step over, not this one now. Step into. If you say step into, so now we are in moveUpBy. You can now we switch the context already. We switch from point tester to point, right? So now let's have a look at something here. There's something called this. I will talk about this on Thursday or Tuesday. This simply means the context object we're talking about, right? If you just switch your context back, point tester, we talk about P1. So this is really P1, the context objects. So if you go back there, you will see that this, if you expand it, is exactly 2.0 and 3.0, exactly the same. Okay? Another way to verify this, I'll show you. Now, can you Can you see this address here? That's the address for the context objects. 6 to 6B, something like that. So now, can we just go back to PointTester here? If you look at the address for P1, you will see that it's also 6 to 6B. Let me show you. Hopefully I can show you that. Oops. If I say system, let me try. Well, somehow I cannot evaluate that. Okay, take my words for granted. You can see that the address actually match. Okay, we are talking about the same objects. I'm not sure why I cannot show that here. Maybe if I expand this PointTester here. Okay, anyway. Okay, let's go back to point here. So now we're trying to do moveUpBy. So now let's see this. Y is currently 3.0. I'm going to add I, which is 2. Right? That's how we made the method call. Right? We're going to add 2 to 3.0. So let's now watch what's going to happen here. If I say step over, you can see Y changes from 3.0 to 5.0. That's exactly what moveUpBy does for you. Okay? After that, so now we're here. After we have executed this, if you look at P1 again, now P1 is 2.0 and 5.0, even highlighted for you already, right? Oh, actually, now we got it. You can see P1 here, it has address 6 to 6B, right? The same address, okay? So they are really the same. Okay, any questions? No? Okay, let's do something very quickly and then we'll move on to the next one. Now let's see how we can use the new accessor method that we have. So now let's say point P2 is assigned to moved P1 dot moved up by 2. Like that. Something I want to tell you about, because we know that P1, so moveUpBy is an accessor method, which means it returns something. That's why I can store the return value in P2. If you simply do this, like this will still compile, as I said in the morning, but it is not useful. Because that one is going to return a new object of type points, but you're not using it. So what's the point of doing the computation, right? Not useful. Okay, let me put it back. So now let's try to debug this again. Okay. So now let me just do this. So this is what I want you to do. If you actually do this, system.out.println, let's print out P1 again. What you really expect to see is before and after I do line number 19, P1 shouldn't change. Okay? I'm only trying to return a new point without changing P1. Okay? That's the only thing I do. We'll make sure that. Okay, let me just say system.out.println. Before calling accessor movedUpBy. Okay, this is before, and let's also print it out here. This is after. We want to make sure before and after we don't really change P1. We're just returning a new object. Okay, that's all we're gonna do. Okay, let's try. Let's verify this, and then we'll debug. You can see before and after 2.0 and 5.0. What about P2? Let's also print out P2. Let me just say P1 over here, okay? P1, and this is P2. P2.x and P2.y, like that, okay? Now let's try this. Now let's observe. So now you can see that, let's focus on P1 first. Before and after we call the accessor method moveUpBy, P1 doesn't change. It remains to be 2.0 and 5.0. P2, which is returned by the accessor method, it represents a new point, which moveUpBy from P1 by 2 units. That's why you see 2.0 and 7.0. But how do we achieve that? Let's see the debugger, okay? Just to make sure I understand that. And that corresponds to exactly what I said in the morning. Okay. Okay, let's now do a breakpoint over here. Right before we do P2 is assigned to P1 that moveUpBy. Okay. Now let's do the debug. So now we are here. Okay, we're here. So let's step into it. First of all, let's observe. If you move your mouse over P1, it's 2.0 and 5.0. That's P1. Okay. Now we're going to call this method with the argument value 2. Okay. And the context object is P1, which means when we step into the method, we're going to see the xy to be exactly the xy for this context object, which is 2 and 5. Okay. Let's step into it. Now, first of all, you can see the context object, which is P1, 2 and 5, as I said. Now, I'm going to create a new point over here. So now we can expect to see after this line here, we're going to create exactly a new point, like this, MP. MP over here is a separate object. If you click on this, it's 626B. This one is 1C4A, different objects, right? Different addresses. MP has exactly the same x and y because we just duplicate the points over here, right? Over here. And now we say that we're going to move up MP by I units, and I is simply just 2. So now that means when we call this mutator method here, we only change MP. We do not change the context object, which is P1. We do not. Okay? If you do that, you can see we only change MP from 5.0 to 7.0, right? That's what we do. And on the other hand, the context object remains to be 2.0 and 5.0. Okay? It's a very important point to notice. Okay? And then we're going to return the MP. So now you can see that P2 now has, over here, if you remember the address is 1C4A. You know, you can see the recording. Okay? It's actually exactly the MP address. Now, one more thing to note, you can see now P2 has 2.0 and 7.0. Okay? And P1 remains to be 2.0 and 5.0. Okay? Okay, any question about this? So this one just shows you how you can step into the method and then to actually see how you can also go step by step within the method. Okay? Any questions? No? Okay. Now I want to spend about 10 to 15 minutes to type some code first, and then I will explain in more details. I'll give you some rough idea, and then I will explain that in more details on Thursday. Now I want to create a new class. And this class here is going to have some attribute that's very special. Let's say new, and then class. Let's call that PointCollector. With the main method here. Oh, no, sorry, no main method, no. And finish. Okay, what's so special about the PointCollector? Well, if you see from the name, it's going to collect points. How do you collect points? Not just a single point, but an array of points. Point, like this, and then let's call that points. This attribute is of array type. Each element in the array stores an address of some point objects. Okay? And now I'm going to show you exactly what the solution is, and then I will actually explain more details. So every time when you have an array attributes, which is going to collect something, you want to gradually expand. First of all, let's do the constructor first. PointCollector. Over here, let's make some assumption. Maximum number of points to collect is 100, let's say, maximum. So you know how to initialize the array to be some certain size. So now whenever we are trying to create a new object of PointCollector, we had to initialize the array. So I'm going to say points is assigned to new point, and then 100. Okay. Now let's do a test right away. Let's create a new class over here, new PointCollector tester with a main method. I forgot. Okay, let's do this. Now, PointCollector PC is assigned to new PointCollector over here. Now let's see what this is going to do. But let me just do one thing for you. So now let's say I want to print out the array. Okay. For integer I is assigned to 0, I less than PC dot. We know that has an attribute called points dot length. I less than, I plus plus. I can say system.out.println. I can say points at position I is this. PC dot. Okay, let me just separate into 2 lines for you. Okay, over here I can say PC dot points at position I. Why don't you take a guess? What's going to be the output? No, right? Because remember, now let's verify this in the console, and then I'll use the debugger to show you why it is not. Oops, sorry. Oh, typo, sorry. Main method. Let me do it again. Public static void main string args. All nodes, which is not surprising because remember in the constructor we only initialize an array of size 100. That's why each slot doesn't store anything meaningful yet. Let's try. Can we put a breakpoint in line number 4 here? Debug. And we're here. Let's now step into it. Okay, if you step into it, you're gonna see the first line. Just go over here. Okay, step into it again. So now we are in the PointCollector constructor, right? So now we're gonna. So now at this point we haven't executed line number 11 yet. So now we're gonna say execute this. Now after this we have points being an array of size 100. Okay, nothing has been initialized yet. We just have the array. Okay, that's what the constructor does. So now let me just tell you briefly the idea. I only got about 5 minutes left. So this is how we're going to do it. Now this is what we have done. So this is PC. So when we say PointCollector in the tester code, PC is assigned to new PointCollector. After this line, we actually got something like this. An object of type PointCollector. There's only one single attribute, which is called points. And it is an array. To be more precise, it is a reference to some array. Right? It's going to point to some array of size 100. 0, 1, 2, etc. to 99. Each one of them is simply null. To begin with. That's what we have seen in the Eclipse. now I want to somehow gradually collect the points. Right? So a very standard way of doing this is we're going to have a mutator method for doing this. Okay? Let me show you. The idea is I'm going to introduce a new attribute. I'm going to call that the number of points, NOP. Initially 0. And the value of this has two purposes. It's going to tell me how many points I have collected so far. So far, no, 0 points. And also the value here tells me what will be the next position in the array for me to store new points. So now, and then in the beginning, it's pointing to here. That's the NOP. If I got a new point here, I'm going to store it here. If I store a new point, I'm going to move this pointer to the right by 1 position, by incrementing it, right? Let's try this, okay? When you understand this, you will find that assignment 5, test number 2. You solve a big part. Let's try this. So this is the standard way of doing things. Okay, let me just say this. We have integer NOP. So I'm going to document this. This counter has 2 purposes. Now, I don't want you to consider this as something new. Remember what we did before. If I say the user might enter maximum 100 numbers, I will initialize an array of size 100. But now the user may not occupy the entire array. That's why we have some extra counter to help us. We're doing exactly the same thing. Nothing new here. Right? We're just adding the context of classes and objects, etc. Okay, 1. Keep track of how many points have been collected so far. Number 2, indicate the next position in points to store a new points. Okay, two purposes. So now we need a method for doing this. I'll show you 2 versions. So now let me see version 1. I'm going to add a point to the PointCollector. Void addPoint. Now let me say version 1. If I want to add a point, I need to know what the x and y coordinate values are for this new point. I can say double x, double y. Okay? So now I can say this. Point, new point, MP, is assigned to new point, x and y, just using the parameter values. And now I want to assign this value here to the array. I can say points at position NOP. Remember the second purpose of NOP, right? It's assigned to MP, and then increment this. I'll show you exactly what happened in just a moment in the tester. Okay, so that's the method we need. If you really prefer, if we didn't initialize NOP, that will have the default value 0. Okay, but if you really like, you can explicitly do that, but not necessary. If you really prefer, you can feel free to do it. Okay, let's test this and then see what happens. PointCollector test. So now let's try this. First of all, system.out.println. Okay, let's say NOP initially. So pc.nop. Initially, we have no points. So that's why NOP should be 0 initially. Agree? So now let's call the method here. Let me create a point. Let's say point P1 is assigned to new point. Oh, sorry, not this one. Let me just call this pc.add point. What about 3 and 4? Just that. And let's see what's going to happen here. And I want to put a breakpoint over here in line number 11. Let's try that. Debug. Now we're here. So PC at the moment, NOP is 0. Everything's null, just like on the board. Let me step into it. Now I'm now in the addPoint method here. Let's do it one by one. Line number 20 is going to create an MP, a new point object. I'll put it here. We're going to have a new point object which is called MP, which has x and y. Now in this case, x and y, let's check. 3 and 4, I suppose. 3 and 4. Okay. 3 and 4 over here. We create a new point, and then we say that. So that's what number 20 will do. If you step over, you will see that there's a new MP over here. You can see for MP, you got x and y, 3 and 4. Okay. So now line number 21. What do? We want to assign MP to position NOP in points. What does that mean? When you say points at position NOP is assigned to MP, we know that each slot of this points array stores an address to some point objects. Now we're giving you this address here, which is MP. So now I can see that NOP at the moment is 0, which is pointing to here. We're trying to say this slot here, rather than storing now, we're going to store whatever the address that is stored in NP, which is referring to this object here, right? So this is what this would do. Now it successfully stored that point. But now the story is not over yet. Because now for the next point to be added, we have to make sure it's stored over here rather than here. Otherwise we'll be replacing the point, right? So now you're gonna say NOP++. That's exactly what the next line will do for you. Okay, after this, we can go for NOP++. So after this, you can see NOP has now become 1. Which means the next time, if I got a second point to add, you will add to here. Okay? Any question about this logic here? Okay. Okay, let's go back to here. So now let's go back to PC tester over here, add points. So now after this, let's see what will be the change for NOP. System.out.println. After adding 3, 4. Okay, let's do this first. Now, what do we have? So now we have, after adding 3, 4, NOP becomes 1. Okay, which makes sense. Now, one more thing to show you. How do we print out all the points in the point collector? Apparently, this one here is not going to do for us because points.length is always going to be the maximum, the rightmost slot. But we may not occupy the all slots at the moment, right? So now I would say, let's just do a few more. Okay. Can we just do one more? Okay. Let's say after adding -3, -4, how about that? Let's do -3 and -4. And we expect to see NOP now will become 2, right? 1 and 2. Okay. Now, one final thing to show you, how do we print out the points? Can we just copy this code here, and then I'll show you. This one here. There's only one modification I need to make in this code here. If I simply say pc.points.length, it is always going to go over 0, 1, 2, all the way to 99. But at this point here, I already got 2 points in the objects, which means we got something like this. Real quickly. So we got another point called x and y. We got -3, -4. And then we know that NOP points to. And then we actually have changed NOP to 2. That's what we got so far. Right? So now, how do we print it out? We want to print out only 0 and 1, but not all the way beyond. Right? How do we do that? The only thing you got to change is to say the upper bound should be PC dot NOP. So this is very similar to how we did things in the one-dimensional array. Nothing new, really. Why don't we try? Oops, except that I need to do PC.points. Let me do that properly for you. Parenthesis plus PC.point.x plus comma plus. Okay, this line is going to be long. Okay, how about this? Let's say print system.out.println. Okay, you got a comma here, and then plus PC.points at position I. You can make it a little bit better by saying this. Current point is equal to PC.points at position I. So I don't have to refer to this every time. Current point dot x. Current point dot y plus, like that. So that would do. Okay, you can see these are the 2 points. 3.34 and -3, -4. Okay. Okay, any question about this? There's actually very little detail I missed over here from the slides, but I would say now you should be ready to transfer the knowledge you learned here to assignment 5. I might do a little bit more explanation on Thursday, but don't wait for me to do that. You should really try doing them right away. Any questions before I finish the session? Okay, so now for Thursday, quiz. Everything from slide 1 to slide 40. Okay. Huh? From if you go to the web, you will see that I posted only 40 slides for the object and class and everything. I'll mention that in the Kako chat again tonight. Okay, if you have a question, please come forward to ask me. Otherwise, I'll see you on Thursday.